Hello guys, Assalamu alaikum. This is Arias Hussein from Elevare. Today we will be looking at a velocity time graph question from May 2024 paper of Edexcel IGCSE paper 1. Um, so over here, the velocity time graph that we have, this is something very important. Velocity time graphs, acceleration time graphs, and distance time graphs are very important in this case that we can find lots of majorities of answered, but you need to properly know how to interpret the answers from each of these graphs. So today we will be looking at the velocity time graph. And let's solve this question number 12. So let's see what's written over here. A car accelerates with a constant driving force along a horizontal road and reaches its maximum speed. This is the velocity time graph for the car's journey. By drawing a tangent to the curve, determine the acceleration of the car at a time of 20 seconds. Okay, so for an acceleration, to find the acceleration from velocity time graph, okay, we need to find the gradient. So the gradient is m. So the gradient is acceleration. Now, here's the twist. They said at a time of 20 seconds. So 20 seconds can be easily denoted that it's here, right? Now, at 20 seconds, we have to draw a tangent. Remember, guys, to find the gradient, we need to draw a tangent and then find its gradient. So if we were to draw a tangent, then we would have to draw, so sorry, we'd have to draw on the linear part of this. So the linear part that we can find here is along here at 20 seconds. Okay. So what if we give a line like this? Okay. Okay. That looks like a good line. Now, how do we use this line to actually get our gradient? So let's get the points of this. All right. What we can do here, what I'd suggest my students to do is to draw a triangle. Okay. So what does the triangle actually do? It actually helps to, you know, it helps to interpret the values for the line. So here we have one line. Okay. Okay. And here we have another. So now we have a triangle alongside the tangent, right? This is a very important thing that you need to show, okay? And it's a good habit if you do it from your O levels because this is something you need in hand in A levels, both AS and A2. So let's find the corresponding values. So over here, this is one value, okay? So let's write down the coordinates of this point. So this should be 10, 12, and the y-axis we have is 28. 12 and 28. Okay. Next point is we have here, this is looks like a 48. And over here, you will have 30. So 30 and 48. Now, how to show the working here? We need to first say gradient. Okay. You can write gradient or you can write A is equals to definitely rise over run, change in y divided by change in x. So we know the formula for gradient, which is y2 minus y1 divided by x2 minus x1. So over here, we have y2, x2, x1, y1. If we were to write here, then we'd have 48 minus 28 and 30 minus 12. So it should be 20 minus 30 minus 12 is 18. 10 over 9, right? If we were to use a subtraction, division by subtraction, if we were to divide this and find the value, it would be 1.11. Now, very important that we write meters per second squared. Okay? So that is the acceleration that we got. So this was very simple, but simple and easy 4 marks. You can easily get it from here. Let's move to the next part. Determine the distance traveled by the car during the first 80 seconds of its journey. Okay. So for the first 80 seconds, it's going to be here, right? Till here. Now, over here, we need to find the distance. And this is a 5-mark question. So it's very important that you know that we need to do a lot of working here. For a velocity time graph, distance is definitely area under the curve. Okay? So we need to find the area over here. Now, how do we find the area? This is a curve. You are not supposed to be getting an area from here, but you can. Okay? Let's erase this part. I think this would be much more clear. Okay, so if we were to find the area from here, oh, my bad. We have to use this part actually. So we need it from the 0 to 80, right? So we need from here. Now the thing is, this is no particular shape. We'd actually need a triangular part for us to know the area of a trapezium. Now, the triangular part is something that we need to draw. Okay, something that we need to draw and something that we have to work with. Okay, so what we're gonna do here is I'm gonna erase this part. Okay, and I'm gonna try to draw a line like this. Okay, so we need to get a triangular part from the 0. The best way you could do this is aligning it here to the linear part. Yeah. There. There. Now, let's do this part, okay? Okay? So now we have a trapezium, right? Now let's get each of its points. All right. Let's get each of the points. So over here, of course, we'll have 80. And over here, we will have, let's say we started from here. So this is 28. So 80 minus 28 is 52. So 52 over here. The height we have here is 66. Right. And yeah, those are the values that we need to know. 80, 52, and 66. So area under the graph, we do know area of the trapezium is half into a plus b into h. So definitely we need to use the values here. So a is 80, b is 52, and h is 66. Half 50, 50, my bad. 52, 80, 10, 66. So our answer should be 4,356 meters. Okay. You can also write it as 4,400 meters. Okay. So that is how we use the area under the graph. The last question we have is explain the motion of the car after 80 seconds. So after 80 seconds, we can see that there's a constant velocity, right? So a constant velocity, okay, means that acceleration is zero. So we can write here, since it's a 3-mark question, we need to write 3 pointers. So definitely we have to write the velocity remains constant, comma, hence the acceleration of the car is zero. Okay, so those are 2 points. Now you might be wondering, what what is the last point that you can write here? What can be the last point that you can write here? The last point you can write here as an additional note is that we do know that F is equals to ma, right? Uh-oh. F is equals to ma. So no resultant force acts on the car. Okay? So that is our question number 12. And for more easy solving methods of questions like this, make sure to enroll yourselves into Elevare Physics classes with me. And till then, Assalamu alaikum. Take care and have a great day. Bye.